What is up, my Form 3? Welcome back to our weekly class. Today, we are going into a new chapter. I hope you're ready. So before proceed, please download the notes and exercise I've attached together with this video. And hopefully, if you want, I would wish that you print it out. I will give you the hard copy when I see you, but I still prefer you to print it out because when you write something, the better you memorize. Okay, all right, without further ado, let's proceed. Okay, this chapter is called endothermic and exothermic reaction. Okay, this chapter compared to the previous chapter is much simpler. So simple. In fact, I can finish this in one class. Just you watch. Okay, so compared to last chapter, this is like kindergarten level. Okay, so let's look at endothermic and exothermic. Okay, thermic, when you see thermic means heat. Okay, thermometer. Okay, so endo means enter, going in. Exo means going out. Okay, so just write in. Okay, exo, endo, not that K-pop group EXO, but you know, EXO is going out. Exit, okay, it comes from the word exit. Okay, so endo, I remember is enter. Okay, so very common sense stuff. Okay, so basically endothermic means heat going in, I'm absorbing heat. Exothermic means heat going out, I'm releasing heat. Okay, so your fridge is doing exothermic. Okay, your fridge is doing exothermic. Your oven is doing endothermic, making your food hotter. Fridge is making your food colder. Okay, so think of it, this is your fridge. This is your oven. Okay, that's why I say very common sense stuff lah. Okay, sorry. Okay, so thermochemistry. What is thermo? Like I said just now, thermo means heat. Okay, so heat chemistry. So what is thermochemistry? Thermochemistry is the study of heat change when chemical reactions occur. Okay, all chemical reactions will have some kind of heat change. There is no any chemical reaction that has no heat change. Okay, even very little. Do you know even adding salt into water, you change a little bit of temperature, it will increase a little bit, maybe by 0.2. That's why you don't notice. It's not like you touch the cup, it's gonna be hot, but just very little because it's a slight small exothermic reaction. Okay, all reactions have heat change. Okay, so exothermic, like I said, exo means going out. Okay, it's releasing heat to the surrounding. That's why when you touch the cup, it feels hot. Okay, because you see, this thing, what you are using is releasing heat to the surrounding. That's why when you touch something, it feels hot. It's exothermic. Like I said, oven. When you touch oven, it feels hot. Okay, so endo is absorbing heat. That's why when you touch a fridge, it feels cold. Okay, so heat released to surrounding. I'll just get to the point. Okay, this is heat released to surrounding. Okay, very simple stuff. Okay, so let's look at the energy diagram. Okay, this is the easiest way for you to understand. Okay, so you have reactant and product. You know what is reactant? Let's say I have acid. Do you still remember last year? Acid and alkali. This is neutralization. When you add them together, you get salt and water. So acid and alkali, what you want to use is your reactant. When you add them together, what you get is your product. Okay, so in exothermic reaction, your product should have lower energy because the energy is really released to surrounding. Okay, when I react them, they release heat. That's why after that, the energy level goes down because I release heat, energy goes down. I'm becoming colder. Okay, so can you see heat released to surrounding? Okay, so what is this delta H? The triangle is delta. Delta H is the heat change. Okay, heat change. You should get negative because it's going down. Common sense? Going down, releasing. That's why it's going down. Okay, so endo is the other way lah. Okay, so reactant, your product should have higher. I'm gaining energy. Okay, surroundings become colder. I'm sucking energy. Okay, that's why the delta H, the heat change is positive. Okay, I'm absorbing the surrounding heat. Okay, so common sense. So let's look at endothermic and exothermic reaction. Okay, so we have two reactions here. Okay, you should do this in school, but common sense stuff lah. Okay, so can you see they use polystyrene cup? Okay, why do they use polystyrene cup? If they ask an exam, this is to prevent heat loss to surrounding. Okay, polystyrene is a very good heat insulator. That's why if you have an ice box, okay, you buy any ice box lah, it's made from polystyrene. Okay, polystyrene is very good in keeping heat. Okay, if you use metal, then it is the other way around. It's very good in conducting heat away. Your ice is gonna melt very quickly, or your heat is going to go away very quickly. That's why you have polystyrene as your heat insulator. Okay, so that's why we use polystyrene cup. Okay, so they don't show the temperature here, but you should get higher. Okay, before you should, let's say 37, you should get around 42 here. Okay, it's very small to see. That's why 5 degrees you don't feel anything. When you touch it, you feel okay lah. You don't really feel anything. Okay, so exothermic. Okay, endothermic is a very funny reaction. Okay, because when you add something, the water actually gets colder. Okay, very seldom you have endothermic reaction unless you have something with ammonia or something with nitrogen. Is it here? No. Okay, oh, whatever. Okay, whenever you see ammonium or ammonia for that matter, confirm it is endo. Okay, because endo has not many example, exo has many example. Okay, 99% I would say of reactions are exothermic. Okay, that's why bombs are exothermic. That's why when bombs explode, it gets hot. Fireworks is exothermic. What else? Let me see. So many things. Okay, bombs is just a very exothermic reaction. That's why it can kill you. It releases a lot of heat in a very short amount of time. That's why it explodes. Okay, it's just a very quick combustion. Okay, so let's look at the question. What is the operation definition? Okay, I hope you still remember what is this. Okay, release of heat is shown by rise in thermometer reading. Okay, read it yourself. Okay, what happens when thermometer temperature show is at maximum or minimum? Explain why. Okay, what is thermal equilibrium? Okay, thermal equilibrium means my heat and when two objects are, I have object A and object B. When they are in thermal equilibrium, thermal means heat, equilibrium means equal. Okay, when A and B is in thermal equilibrium, they have the same temperature. Okay, I'm sure you have tried this before. You stick your face onto a metal surface. Very cold. Okay, but after a while, it feels the same as your temperature. You don't find it nice anymore because you have already reached thermal equilibrium. All your facial body heat is really released to the metal. The metal gets hot. You guys are the same temperature. It's called thermal equilibrium. Okay, means same temperature. Okay, thermal equilibrium. Okay, so yeah, one more thing here, number 4. How can the accuracy be increased? How can you make this experiment? Okay, even you use polystyrene cup, there will still be a little bit of heat loss. You can't get 100% no heat loss. There's no such thing in this world. Okay, so how do you make this even more accurate? Okay, besides using polystyrene cup, okay, you can wrap the polystyrene cup with cotton wool. Okay, use a lid. Okay, a lid actually prevents heat loss. That's why when you are cooking water, okay, cover your water, it boils quicker. Okay, so let's look at example. Okay, where do you see exothermic? Okay, exothermic is everywhere. Okay, respiration gives you heat. That's why you feel hot. It keeps you warm. Okay, have you noticed when you are in a very cold room, you feel cold? After eating, immediately you feel warm. Okay, eating makes you warm because when you eat, you are breaking down food. Respiration increases because you're breaking down food. That's why you feel hotter. Okay? Eating makes you hot, especially in such a hot weather. Okay, what else? Burning. Okay, it releases heat. Common sense. Neutralization. Okay, you learned this last year. Neutralization is exo. Your cup is supposed to feel hotter, not hot, not as in boiling hot, but hotter. Okay, thermite. What is this? This is a bit out of your syllabus. You don't need to know. Okay, thermite is actually a very strong combustible stuff. Okay, this thing is so strong you can burn through steel. If your steel is like 10 cm thick, let's say you want to break into a tank, okay, an army tank, you can use thermite. This is so strong. okay, because it's a very exothermic reaction. Okay, freezing or what is this here? Okay, freezing of water, yeah, this is exothermic. Okay, my mistake. Okay, you're releasing heat, you're making the water colder. Okay, anyway, endothermic, when do you absorb heat? Number one, photosynthesis, you absorb sunlight. Okay, you absorb heat. Number two, baking a cake, like I said, oven. Yeah, oven. Okay, so you're absorbing the heat. Okay, and then what else? Evaporation of water. Okay, what else? You see, whenever you have ammonium, it is confirmed endothermic. Melting of ice, which is the opposite of just now lah. Okay. Oh yeah, there are a few more examples here. Okay, so where else do you use exo? Hot pack. This is opposite. Okay, what is hot pack? You can find this in pharmacy. If you feel, I don't think you can find, you can find cold pack easier. Okay, what is cold pack? Cold pack is actually two substances inside the bag. They are not mixed together. If you want to use it, you just press them together. When the two substances mix, it will turn cold, and then you use it to ice or whatever muscles that you're injured. Or maybe you have played basketball or any sports before, you hurt your joints, and then they use a kind of spray which is very cold, and then they spray your joint. Okay, why is that so? Because if something is cold, okay, you can ask St. John. The best emergency treatment for any injury is RICE. R stands for rest. You need rest. I stands for ice. When you use ice to reduce blood flow, you're not gonna get inflammation. It's not gonna be swollen. Also I. C is compress. You press, okay, to reduce the blood flow. Same concept as just now. E, elevated. Let's say you injured your knee, injured your leg. When you sleep, you raise your leg. Why? Because less blood flow. Again, you make it recover faster. So this is heat pack, cold pack. Okay, so heat pack is, let's say you have muscle tense. Okay, you use this heat pack to increase the blood flow to make this part feels better. Okay, so same concept lah. Okay, so what else? Sodium hydroxide to clean drain pipes. Okay, you can read this yourself, not very important. Okay, glow sticks. Okay, or we call it flare lah. Okay, you use this to generate light. Let's say you are diving, you watch those military movies or you play games, you can use this flare. Okay, so what else is endothermic? Okay, rusting. Okay, rusting actually absorbs heat. Okay, very small amount. Okay, so vacuum flask used to maintain high or low temperature. Okay, so vacuum flask is thermos. Okay, basically your 保温瓶. Okay, your thermos basically it keeps whatever you want inside, cold or hot. Okay, this thing is so amazing. Okay, you keep thermos, you keep your ice in thermos, I think for even 6 hours the ice will still be there. Even 24 hours, I think the ice will still be there. Yeah, it will be a bit melted, but still there. Okay, there, we are done. You call this a chapter? Okay, it's too short to be a sub chapter. Okay, come on, so simple. All right, so let's go into exercise. Okay, so is it exo or endo? Burning, exo. Yeah, I'm just write X or N lah. So what is this? I think this is photosynthesis. Endo. Okay, what the hell is you doing? This is respiration. Okay, respiration is exo. Okay, cooking food is endo because you're making the food absorb heat. Okay, fireworks, exo. Melting of ice, endo. Okay, you're sucking heat to make the ice melt. Okay, so define what is endothermic reaction. Okay, a chemical reaction that absorbs heat from surrounding. Okay, the key point here is absorb heat. Okay, exo is release heat lah. Same thing. What is thermochemistry? Okay, the study of heat change. Okay, in a reaction. Okay, RXN is reaction lah, short form. Okay, so this is exo, this is endo. Okay, so is it true or false? X is exo, correct. Okay, I'll just tick here lah. Okay, just write T lah. Okay, heat release in X. Okay, true. Temperature of the environment will decrease in X. Okay, false. Okay, Surrounding will get hot, not cold. Okay, heat is absorbed into the environment. You see, this is a trick question. Heat is absorbed into the environment. This is false. Not absorbed into the environment, absorbed from the environment. Okay, you see how they trick you, this kind of question. The temperature will increase of the environment will increase in Y. False. Okay, surrounding actually decrease. It will be colder. Okay, so what is exo? Okay, so what is exo? Exo is release heat. Okay, endo is absorb heat. Oxidation and reduction happen simultaneously. Oh, so this is nothing. Okay, so exo, what is exo? Surrounding temperature rise, correct. Absorbs heat, no. Reactants have more energy than product. So reactants higher than product, correct. Reverse reaction means can it go backwards? No. Okay, this is not your concern. Okay, so absorb heat, this one release. Increase, decrease. Okay, so when you see ammonium, you should have lower reading. You should get around 20 degrees Celsius. Okay, explain your answer. Okay, this is endothermic reaction. Okay, like I said, whenever you see ammonia, it's confirmed endothermic. Okay, no matter ammonia what lah, not your concern. When you see ammonia, it's confirmed endo. So Rizwan and his friends carry on an experiment. They mix water with PQRS. Okay, and then they read the temperature. Oh, temperature decrease. This is endo. Okay, increase, exo. Increase, exo. This is decrease. This is endo. Okay, what can be observed by Rizwan? What can be observed by Rizwan? So many things you can observe. Okay, so for A and D, final reading. Oh, A and D becomes colder. Okay, for B and C, it becomes hotter. Okay, or warmer. Based on the observation, Rizwan make two inference. State the two inference and explain. Okay, A and D, they are endothermic. So explain. Why? Because it absorbs heat from surrounding. Okay, so BC is the other way lah. Okay, BC is exo. It release heat to surrounding. So simple. Okay, so sketch this. We already know A is endo, B is exo. So draw your graph lah. Endo should look like this. Reactant and product. Okay, it gets heat. So the delta H here is positive. Okay, exo is release heat. Okay, reactant, product. Okay, if you can't score in this chapter, I feel sad for you, seriously. So easy. That's why it's not going to be asked much. Yeah, PT3 is cancelled. Why do you care? Okay, so based in C1, explain the following types of reaction in terms of energy change. Okay, based on C1. Okay, for A, they want energy change. Okay, energy of product is higher than reactant. Okay, so B is the other way. Reactant higher than product. Okay, so shows from an experiment, blah blah blah. So can you see B is exo? Okay, and then A is endo. Okay, between A and B, which is exo, which is endo. Okay, so B is exo, A is endo. Okay, you should get 2 marks here. Wow, like that also 4 marks, huh? Okay, so why is it exo? Because B, okay, temperature of B increases. Okay, release heat to surrounding. Okay, so A is the other way lah. Okay, absorb heat from surrounding. Ay, so repetitive. Okay, give one example of exo. So where do you see exo? The best example is freezing of water, endo melting lah of ice. Although it's so simple. Okay, burning of petrol is exo, photosynthesis endo, exo, making bread. Bread absorbs heat, endo. Neutralization exo. Rusting is actually rusting. Rusting is exo. Rusting is actually exo. It gets hotter. It's a type of reaction. Okay, so burning of candle is exo because heat is released. Exothermic in the body increases body temperature. Wait. Exothermic. You're releasing heat. Now this is where it gets confused. Is it releasing to the surrounding? No, it's happening in the body. I'm not releasing to the surrounding. That's why it increases body temperature. Okay, very tricky question. Okay, exothermic is applied in instant hot pack. Okay, because it gets hot. Baking a cake is not exo because heat is absorbed. Okay, the cake is absorbing heat. Okay, let's not finish this. Okay, so I will continue this next week. It will be a very short video next week. Okay, I might not even post the video. I might straight away post the answer. If you can understand what I'm talking about so far, you can definitely understand the next few questions. Okay, we're halfway through the exercise. Okay, so thank you again for listening. Thank you again for paying attention. Okay, I hope you learned something today. I hope you're staying well at home. Okay, I hope you're not crazy yet. Okay, I hope you're making good use of your time. Okay, so same time again. I will see you again next week. Okay, stay safe, learn something, and bye-bye.